weight. For instance, we have these anthers. That is a very easy way of making a characterization of a population. That is, you take a height from the average plant, you take the uniformity. It depends. The uniformity from 1 to 9, and it begins 1 to 5 for populations, and then you have for 5, sorry, 1 to 4 for populations and 5 to 9 twin breaths. Then you have the angle of the leaf. So if you have 45 degrees or less than 45 degrees and you use the leaf above the ear. We have the tassel, because in some cases and with the fasciation trait, we have really very ramified tassels. So we need to know what we are dealing with. The ear, what is the position of the ear, and then a very important and really important for us, that is the root lodging and stalk lodging. So it means that what is the percentage of the plants that fall down by the root or break. Yeah, and if we ask if it's possible to connect this with, for instance, with secant linked, it's very easy to do it. Another selection procedure that we have but generally for when we are doing the selection in the farmers' fields, or even for our in on station, we can do it in 3 steps. Sorry, this was with a lot of text, but I think it's easier for you to go in. Generally, we don't do this at least at that farmer level. It's quite difficult, or it needs that the farmer are really extremely engaged and have the time. That doesn't happen too much. Because it means that before the pollen shedding, you do the detasseling of the undesirable plants. So you take the one that have pests, that have disease, that are weakest, that you don't like, but at the end, you have that plant. That plant produces the kernels, the grain that you use for bread or any use, but you don't use it for the next step of selection. Then you have the traits that we can select. That could be the size of the ear, if it's prolificous or not, if what about the health of the plant. You should look and say that you have diseases, you have pests. You can monitor it, you can rank that. You can see also in the root. How is the architecture? Is the plant height, the insertion of the ear, if you have what is the angle of the leaves? So all these, as you see, are some of the traits, but are key traits. They are addressed for a certain goal. So they make a methodology that is useful for our breeding goals. This is in the when we are doing the harvest. And when we are doing the harvest, we need to know also a very important stuff that is very unique, very easy, but has implicit some very crucial information. That when you look at the plant and you like the ear and you almost do all this, at the end, you give a kick to the plant. Because when you kick the plant, not as a football player, please, but when you kick the plant, if it breaks, it means that there are some fungi, there are some insects that are destroying the plant. So you got this information and you don't select this for the next season. But again, these are the traits, the some of the description that makes also a methodology for a key traits for the next agronomic traits that you want that be present in your crop. At storage level, we have the elimination of damage years, disease years, and we try to get selection pressure about 1 to 5%. That's important that we have generally more percent. Why? Because if we select too much, it means that your diversity will be less and less. So we cannot be greedy on this. We need to have a balance. And I'm going to show you some of the work that we did. That's that consists of the theoretical reasoning employing assuming that all the pollination occurs under gravity influence. Well, I'm going to show you first starting this. This is the when the beginning of male flowering happens. So we need to go to the field and check if this did happen or not. And we need to know also when it was finalized. So when the male flowering did finalize. We do this also with the female flowering. You can see here the silks are quite erectophilous, and then the silks were already pollinated, so they are not irritated anymore, and they will dry. This time that you pass it from A small to A big, it means that the beginning to the end of male flowering, and also to the beginning of female flowering to the end of female flowering, it's needed to be measured on the field. And when we do this, we count from the sowing, not this stage, only to show you that there's a plant, from the sowing to to this and this and this and this. So we use it 826 plants from one variety that is Vertial da Perrela in Lousada, and we use these 4 sets. And we assume certain aspect that is the pollination occurs only under gravity influence. So that when maize plants has the hypothesis of flowering, the overlapping of this selfing probability will have a direct effect on the inbreeding depression. So this means that when this is happening, and this is happening at the same time, you will have a full overlapping. But there are different ways that we are going to see. So this method enables the knowledge of the population concerning the relative amount of theoretical allogamy versus autogamy. And a formula was developed to deal with this problem. So the number of days from planting to these several stages. So the evaluation of the overlapping index conditions indicated that overlapped index is limited to 1, so it means 100% overlapping, or overlapping index is either positive, we have some overlapping, or negative. In this case, the overlapping does not occur. It means that you have a plant that produces pollen, but the pollen will not fall on the silks. So maize breeders always look for high functional allogamy, so the selection for negative values of overlap index is pursued. The proposed evaluation method can be conducted in only 1 year. That's what we did, and we obtained these 13 cases. As you can see, what I was telling you, if you remember about A, that is the male flowering and the beginning and the end, and the female flowering, the beginning and the end, you see that there's no overlapping. It means that the seed obtained here, because this is the female, the seed obtained are all obtained by allogamy. But in this case, for instance, you have a full overlapping. It means that you can have uh, pollen from the same plant or pollen from other plants. So this is the cases that we understood that existed, that Silas Pego understood that existed, and we made this formula was made by him, and I collected the data, and we obtained this. We distributed the population plants by these several percentage of examples. And we can see here that is the A small a and the A big, that you have a big interval among them. And here again, you have also a big interval. This indicates you, imagine that you have a year. It's like that you have the peak of the year, the tip of the year in the 72 and the bottom of the year in the 64. Okay, in this case, we have the 67. It's really the grains started to be produced in 67. We have the some allogamy and autogamy until the 69, and then there's pollen from the other plants. This indicates you that we have the distribution of the several cases in our plants. So what we conclude about this population, it was 90% of overlapping, was less than 0, so it means complete allogamy. 15% of complete overlapping, possible selfing all along the year. 60%, 66% of partial overlapping, possible selfings in specific parts of the year. And the population is represented in more than 50% of the cases by partial overlapping of the type T11. So this means that it's generally what we know, that it's the pollen starts to appear, then the silking, and then the pollen stops. And even in this case, our results show that 46.3% of the kernels could have been selfed, while 53.7 are hybrids. So an expected amount of complete allogamy constitutes a selection potential for increasing allogamy at the expenses of a possible autogamy. And these figures, they provided us some differentiated peaks that indicated in some cases that some population is not well recombined. And when we don't have well good recombination, it means that we will have more selfings. And if we have more selfings, we will have less production in our populations. So it suggests it to be composed by at least three subpopulations which almost do not overlap. This represents a potential for both recombination and further genetic diversity implementation. Well, this needed to be more studied, but indicates you some of these important of exploring some of the traits that could be key traits in the selection of our genetic material. So other aspect is what environments to use, because as you remember in the morning, there was mentioned by Professor Adrian that in some cases you have some traits that independently from the environment they are constant, and that's good for identification of a certain variety. But for us, there's important also that some of the genetic and the environment and even the management system, because we have remember we can have also our microbiome and our organic could be very influenced with the environment that we use. Well, and when we are talking about this, we are talking also about the traits that we need to use. And these traits need to be organized, and then we have and thank you for this the information from Isabel and Yannick that provides us more information about how we should organize this data. But this data, we need to know how they relate themselves and how can they help us to understand some of the more complex traits. And here you have the yield, moisture, flowering, overlapping index that we have already mentioned, root lodging, stock lodging. So this is in the field level. And then this is for year level. I will not go in detail, but this year, for instance, is the length of the year diameter, then the cob diameter, kernel diameter, etc. These information are important for the characterization of our populations, and according if really the traits are important for us, and then we need to do the statistical analysis and some of the correlations and other traits or other analysis that was shown in the morning, like PCR, etc. Okay, this is an example about another. This is another example. We can call it the example 2 that was organized for organic and conventional. In this case, we are using some other traits, but we were interested in using the rank. We organize our populations in the organic field and in the conventional field. And we wanted to see what were the behavior of them, and we rank them. Was the work of the master degree of André Pereira, and we wanted to know about, for instance, what happened if this accession that was first in organic, when we compare it in the conventional, we see that we have it's in the 19 rank. Even that it has more yield, but it's in the 19 rank. Then you see that the rank difference is it's 18. Um, it has around 50, so it's almost in the one third one of the table. Then we have also the another rank, another another accession. This accession from Azores that it was in the second round, and when you talk it about conventional, it will go to the uh, um, to the 21, so the difference is 19. And some cases you don't have such a big difference. For instance, this in the rank number 6 in the organic, for instance, it was the rank number 5 in the conventional. So it means that you have here a more stable uh, population, but in the other cases, you have a more adapted population for a certain conditions. So it's better when you are choosing some of these um, varieties to choose some of these best varieties for your organic efforts. So it's important that we know what are the resources that we have. Um, for instance, if we are selecting for drug tolerance, resistance based on yield, and sometimes it's complicated um, due to the complex nature of traits. And this is even worse when we have low irritability. So it means that the ratio of genetic by the by phenotypic. The task becomes particularly complex for participatory breeding approaches in which selection tools are needed to be applied by directly by farmers. And another complete difference, but in order that um, to continue to have you with me, I we did uh, this trial, and we asked for the the consumers to choose what were the tomato that they like it more, and the one that had the best color, so the shape and the color, in order that they could select. Number 6 was the winner in our school when we did these results at ESAC, and followed by numbers 5. This is quite interesting. Sorry, followed by number 3, that was the first one here. So this is quite important because when we are doing some of local breathing, some initiatives, um, we should know better what are our address people, because otherwise we end up with some breeding material that it's very important for us and it's very nice for us, but not interested for the consumers that we want to address. Well, this is we could have a long discussions with this, but it's only to show you that it's important. That's why some of the culinary breeding, some of the other aspects of participatory breeding can bring some information that sometimes doesn't exist in the in the normal stream. So other thing that I asked was sorry, whoops. I was a bit afraid of this, and it happens. Okay. Um, I will continue. Well, the other we were talking about some initiatives in terms of traits, of key traits, and one of them was how to select these key traits. And what we did, another example, we did in case of maize to select some of the key traits. You can follow more the information on this paper. And what I have here is that this was the formula that was created when there was a competition that it was called the best year of Sousa Valley. And in this best year of Sousa Valley, there was different types of years: yellow, flint, and dent, white, flint, and dent. So there was this competition, and you can see there was a nice prizes. And in the first year, the things doesn't uh, were not very sophisticated, but then the breeder knew about this, uh, talked with the organizers, and introduced this formula. However, this formula was uh, by his knowledge, his scientific knowledge. Um, so he selected the kernel weight, the length, uh, the number of rows, and because there was the kernel number of the previous uh, competition, he let the kernel number. So what we did was we wanted to uh, connect with the information that was on the year that could change a lot, as we know, but the information that the farmer can know in order to make the selection. Because other thing that it was quite interesting is that in this competition there was the information from the uh, from the breeder about the number of rows, the length, so the description of all the traits that we use in breeding. So in the room where we are getting the prizes, the farmers were needed, or at least they were care about what the traits were at that. Some of them, obviously, they probably know much better, but others, they were not so uh, aware about that. And this was also a quite important tool because in a less sophisticated way, as Isabel and Yannick described it, um, but they it was a way to systematize some of the traits that the farmers need to do the selection procedures and what the the traits that could bring more yield to them, or at least a best year. Um, so because this competition, we didn't know nothing about the what happened in the field. I did a lot of farmer fields, and we collect some of the data of these accessions. So we had about 350 entries that were used for making a model that could help better the farmer and us. Well, this was some of the inside of the tools that were used. For instance, this is random forests, and this in this random forest you have the yields as a key trait, and then what are the traits that are more connected with the yield. So this gives you an idea. Okay, kernel ear weight, kernel weight, length are more connected, for instance, than others. And this was important for our decision. This was the steps that we followed. I will not get in very detail with this, but we had a tenfold cross-validation process. We did train with these are some of the models that were used. And these models were used to train with this 9 fold cross, and then we used one to predict and to build to build this model. So we had from this a result, a matrix with 350 predictions for each one of the 11 methods, and then this gave us 20 a random split of 350 instance columns of the yield prediction, a matrix into 14 random groups, because each group had 25 columns, and then there was a ranking valuation using a measure that was developed for each one of these 14 groups. Then there was a statistical validation, and at the end we generate a new formula that was this one. So it's not a very difficult process. This with a normal machine you can do do this, because it's kernel weight, its length, row number average, and the kernel number, and you got the year value, and then you rank your years according that, and you can in the process, at least in the process, you know that there are some traits that are more that influence more the yield than others. And this is quite important, because when we are talking with a farmer, we need to tell and we need to explain that he could select what are the traits that he wanted to select, but our duty is to tell them that there are some traits that are negatively correlated, for instance, with yield, and we should tell them. For instance, if they want to select smaller ears, it means that it will lose the yield. So I would like to make some uh, resume about uh, our uh, um, class class or meeting, or the what why agronomic traits of interest in organic are important, and there are some limitations. There are many descriptors, but better to work with those which best encompass the diversity present on a crop and its relatives. It's important the comprehensive and discriminating ability. The characterizations with many descriptors of a crop variety is not enough. search for the traits that respond to agronomic questions, search for better correlations with complex traits such as yield, or could be also as stress tolerance or other. Essential to better fit the varieties to organic environment, like nitrogen use efficiency, the weed competitiveness, the pest and disease resistance, and focus on traits prioritized by farmers, processors, and consumers because, at least in our cases, we are working with them. And check the level of diversity you have. Check in the beginning, and it's important that you check during your process. Don't be too strict, otherwise you can improve, but then you will lose this diversity that is the important to cope with the other aspects. In comparison to other and some accessions in other locations and actors are really important, as we have saw in the case of tomato, that in our example we have some um, results, but in other cases you could have a completely different results. So this is important to have clearly in mind. I'm sorry. Whoops. Uh, Sorry, this was something that. So there's some practical exercises. Maybe we will not have time for today, but it's an example Excel compiled data for overlapping index in maize, and some of our field works that you can use it, for instance, to do some correlations, to see what are the correlation more related with the trait that you want to choose, if it's the length of the year, if it's the yield, or other. And there's also some information in the Seed Linked page. Well, I think I have some time. Okay, this was the case of the overlapping index, and you can see here the cases that you have and the year type. For instance, you can with a year that you choose from your own uh, uh, data, from the data that I provided you, you can make a different you can make a different and indicate. Let me. So you copy this and you go to the year type, and if you use this information here, you can sorry, you should be you should do another type of year. Okay, so here you have the average of this one and this one. You And with this information, you will have the the type of kernel of overlapping index. In the case of tomato degustation, for instance, one of the questions that you can then use in this quiz, I hope that, don't know if it's work or not. It's consider the file degustation. What was the accession with either higher acidity? How many overlapping cases exist? It's one of the questions that you can use. So the debate is revised um, that on previous experiences, other questions and doubts, and what we have learned today and proposed homework that is study cases, consider a crop that you are working and identify the 5 top traits that you'd use in a breeding program. And thank you. I didn't see the
I think
yeah,
having a look if there is some comment or questions.
yes.
No, I can see some problems accessing the form, but I think it's solved. Mm.
Yeah,
No, no more questions, Pedro.
I was trying to share with you the other for the questions. Adrian, just a second, because I wanted to check something here.
Yeah, people attending is asking about the fast quiz.
Okay.
Should it be sent by email or the answers or
Yes. Yeah. They can uh, they can send it by they can send it directly, but
okay.
let me. Was I put it now in the I was in the presentation mode.
Mo rí màá attend sí lọ́la.
Um, well, okay, this was the information from the tomato that I show you, but that there was other questions that were not.
Okay, this was
So
the.
this is, yeah, because sorry, I had the problem and now
Mhm.
it's okay. In a breeding program, you should measure all your accession with all the traits indicated by biodiversity. And well, we have this 73% and the 26 yes. So generally, as I told you, we have, depending on the resources that we have, and if we expend all the money in the doing all the measures, probably we'll not have the time to concentrate in the key traits. But yeah.
Mhm.
So the agronomic traits are equal to agronomic traits for organic. Well, in this case, the agronomic traits for organic generally can be specific, can be included, but there are some agronomic traits that are not at all uh, equal to agronomic traits for organic. Remember that, for instance, for weeding and weed resistance, uh, the there's no interest, because if you apply herbicide, the populations will not evolve. Or at least there's no interest in the population evolution uh, to um, to the herbicide. But if they are inorganic, they need to cope with. They need to be tolerant to weeds. So they need to. So equal is not equal. And then nitrogen use efficiency is a simple trait, and generally is a more complex trait because it's related with other with several other traits. Okay, then this was the
Okay.
and then I think the other it's working now.
Okay. Okay. The second one, because some people in the chat is asking
Yeah,
for.
yeah,
I
sure.
thought he meant Pedro mean there was a second quiz.
Yeah, the fast quiz.
Okay.
And this is a fast quiz that I need to send you.
Yeah. Maybe you can put in the chat, Pedro.
Yes, I will put on the chat.
Hmm?
Okay, we if I cannot use this, you can answer on this one and to this one. Okay. And the questions were about the quiz, right? Adrian, are there, and Petra, are there any? Okay. Okay, finally, sorry. I'm new on this. Thanks to you, I'm new on this form, and I've submitted that, so you can do it.
Okay.
Okay, and then I will. Yeah, that's okay. Well, Adrian, that's all. I want to
Mhm.
thank you for all your attention, and remember that we will have the Eucarpia conference in the 26th to 28th
Mhm.
of May of this year. So if you are interested, please
Mhm.
go there. There's nice um, a nice price for students.
Good. Good. Yes. A nice. I'm sure it will be a nice and incredible conference, Pedro. For sure.
I hope so.
And for sure. For
Hope
sure.
so.
There is several people here from Spain preparing the trip for sure. And I think that for the from the rest of Europe. Okay. There is a question from Estelle. Can we have access to the file mentioned in the form to
Oh,
explore it?
thank you. Thank you, Stel. Uh, okay. Thank you very much, Stel.
You're
I should put it.
welcome.
I should put it this on the
On the chat.
on the yeah on the chat
Okay.
on the
And
same the questions
just
on the
another question, Pedro,
yes.
which is, could you please rewrite the question for the homework?
Okay.
You can put in the chat if you want.
Yeah. So it's the consider a crop that you are working and identify the top traits